In Salvona, we continuously innovate and find new microencapsulation technologies to support our customers, enabling them to compete with enhanced stability, additional efficacy claims, safety, and marketing position. Salvona has over 20 years of successful experience developing and manufacturing microencapsulation systems for skincare. In this webinar, we want to inform you about Salvona's innovative smart encapsulation systems and their value to you. We hope it will encourage you to have your own customized system for technology and marketing reasons. Encapsulation is a physical chemical process in which an active ingredient is surrounded by a polymeric wall that isolates and protects the active ingredient from the environment. Salvona offers 5 proprietary encapsulation technologies that are different in structure, properties, and features. These are SalSphere, Multisal, Hydrosal, Microsal, and SalColor. Hydrosal and SalSphere are liquid, while the other are solid, fine spheres. Nature created encapsulation, and we only try to imitate it by creating a structure similar to a living cell. All cells have surrounding membrane, and molecules can selectively move across the membrane. In traditional encapsulation, there is a membrane that helps control the release of the encapsulated ingredient. For example, in liposomes, the membrane is very fragile and easy to break down during light mixing. It has limited value for effective delivery. Let's talk about the characteristics of Salvona's smart encapsulation methods that are used as delivery systems. Microspheres can vary their size from 0.1 of a micron to several millimeters in diameter. Microspheres can be used to enhance stability and extend shelf life. There are small storage units with high concentration of active ingredients. The outer layer has multiple functions. It enhances active ingredient stability by isolating the active ingredients from the environment and preventing oxidation and degradation. Here are a few examples of how Salvona's encapsulation systems enhance stability. Example 1. Stabilizing polyphenols. Polyphenols are very strong antioxidants, and we encapsulate them in SalSphere natural anti-aging. The active ingredients include resveratrol and procyanidin. These are encapsulated in solid natural matrix that isolates them from the environment, resulting in longer shelf life and higher potency antioxidants. The second example shows the efficacy of encapsulating highly volatile ingredients such as menthol. Formulation with menthol is challenging because menthol is available as crystals and it needs to be solubilized before formulation. Menthol is encapsulated in 2 steps. We start by encapsulating menthol into submicron spheres, and then the submicron spheres are encapsulated into multisal microspheres. The submicron spheres allow to solubilize the menthol crystals and sustain their release, while the outer layer, the shell, entraps possible menthol vapors to reduce premature release. The release occurs only after the breakdown of the shell. The third example shows the stabilization of retinol. Retinol is a powerful antioxidant that is unstable and changes the product's color. In addition, It can be aggressive on sensitive skin. Retinol is encapsulated in double layers to protect it from oxidation and sustain the release once applied onto the skin. Passive and active release systems. A passive release mechanism meaning that the system starts to release immediately after manufacturing. Therefore, these systems have a limited shelf life and potency. On the other hand, active systems have a built-in intelligence that controls the release of the encapsulated ingredients. Let us look at the kinetic of release to understand the value of smart delivery systems. We are analyzing the active ingredient level as a function of time. The goal is to deliver at the adequate level and for a longer time. Any overdose can result in irritation, and a lower dose has no contribution. When applying a product with free, not encapsulated ingredients, the skin is exposed to all the active ingredients at once. The high level can irritate the skin of consumers with sensitive skin conditions. A short time after application, the level of the active ingredients drops below the effective level. The actual contact time of the active ingredient at the effective concentration is typically short to activate most biological processes. A smart sustained release system releases active ingredients at the effective level in small dosages for a longer time. This kinetics gives the skin time to buffer and gradually absorb the ingredients. This feature is very valuable for consumers with sensitive skin. The next feature of smart delivery system is triggered release. These systems release the encapsulated ingredients mainly when triggered. The trigger can be change in the proximate environment, such as change from low to high water activity, and by rubbing the product on the skin. Here are a few examples. Multi-cell lip Vantage is a technology designed to plump the lips. It releases a plumping peptide and a sensory agent to signal the action. The activation and the release occur only when the lips get wet. Another example is multi-cell fragrance. It releases fragrance when exposed to moisture. This is an ideal system for an anhydrous product such as a deodorant stick. The fragrance release is triggered with the body moisture. The third example is taking advantage of elevated levels of specific proteolytic enzymes available in irritated skin such as acne. Sunsphere Even Skin is a technology designed to diminish acne pimples by releasing salicylic acid. In this system, the salicylic acid release is triggered by proteolytic enzymes around the pimple. The enzymes can digest the matrix of the spheres and accelerate the release of the salicylic acid at this specific location, avoiding overexposure to acid and possible side effects. The triggered release system allows for extended stability. The intelligent engineering of such systems allow to turn the system from off, no release when in the jar, to on, meaning continuous release when and after it was triggered.